Hello students, today we are going to talk about the new topic polarization of light and types of polarization. We shall also learn that how a light is polarized and what is the difference between ordinary light and a polarized light. You see, a light is electromagnetic wave. This we have extensively studied in the previous chapters. Well, you see, in any electromagnetic wave we have two mutually perpendicular electric and magnetic fields varying with time and varying in same phase, while it propagates along a direction which is perpendicular to both of these, direction of electric field and magnetic field. So this could be a simple illustration for the electromagnetic wave. Now, as a matter of fact, when light is incident on our eyes, the eye is showing sensitivity towards the electric field variations in electric field of the light. It is not sensitive towards the variation in magnetic field. And so therefore now onwards we will talk in terms of electric field present in light and ignore the presence of magnetic field. Now, if we consider that a light is traveling from the board towards you, and say the direction of pen is showing the direction of propagation of electromagnetic wave, then we have electric variation in electric field in all directions. How this is possible? Well, you see, light is a bunch of photons, and each photon is having energy packet. So every photon is having its individual electric field variations and magnetic field variation. And since there are so many photons, they have a random direction of vibration in electric field. They all are perpendicular to the direction of propagation of electromagnetic wave, essentially. But their direction of vibration means the direction of their electric field varies from photon to photon, and since there is abundance of photon, so we have a probability of having electric field distributed uniformly in all directions in the plane of the whiteboard. And this is the situation for a ordinary light, which is also known as unpolarized light. Now onwards we will refer this figure as a figure to express the presence of ordinary light. So here, this is all about the light, ordinary light. Now we will talk about a tourmaline crystal or any another similar crystal which is having a special characteristic, which it means that it allows the vibration in electric field in one particular direction only. That is, those vibrations which are parallel to a particular direction which is known as optic axis of the crystal, tourmaline crystal, that is shown by red line. When a ordinary light is incident on and allowed to pass through the tourmaline crystal, which is also known as polarizer, the vibration in electric fields, those vibrations which are having direction parallel to the optic axis of the polarizer, they are allowed to pass through the crystal, and others are disallowed, means they are absorbed by the tourmaline crystal. So finally what happens, while we were having vibration of electric field in all directions in a plane which was perpendicular to the direction of propagation of light, now we are having vibrations of electric field in one particular direction only, and therefore this light is said to be polarized. and as the locus of all points is a plane, it is confined, the vibration is confined in a particular plane. That was the plane which was lying, in which the optic axis was lying, and that all vibrations were restricted, confined in this particular plane, because only those vibrations which were parallel to the optic axis were allowed to pass through the tourmaline crystal, and so the outcoming light is called plane polarized light. Why we call it plane polarized? Because it is restricted, the vibration of electric field is restricted in a particular plane. It is contained in a particular plane, it is confined to a particular plane, and no vibration, no electric vibration is existing in any other direction other than those in the direction of that particular plane. Say for example, the whiteboard here is the particular plane in which the electric vibration exists, and in no other plane the electric vibration exists. Such type of wave is known as polarized light, and since the locus of all points having vibration in same phase is a plane, therefore we call it plane polarized light. Now we can have another type of polarized light, say circularly polarized light, elliptically polarized light. In those cases we are having two different electric fields, and they superimpose to produce circularly polarized light. How this happens, we will understand it. Say if two electric fields are having same amplitude of vibration sorry, then in that case, and if they are at 90 degree to each other, these two superimpose to finally give the locus of a circle, and those light are known as circularly polarized light. In that case also you will see that the two mutually perpendicular electric field vibrations, their resultant will be in a particular direction, and this group of two electric fields is obtained from various other particles, so that we are finally getting the whole locus of circle, and that polarized light is known as circularly polarized light. If instead of having two lights mutually perpendicular but they are having different amplitudes, then if they are superimposed and keep rotating about the axis of traveling, then the final locus is obtained is elliptical, and that light is known as elliptically polarized light. So now how we are going to detect a plane polarized light? Detection of a plane polarized light. Well, when our ordinary light is allowed to pass through a polarizer, that is tourmaline crystal, what happens? The emerging light is plane polarized light. This is plane polarized light. And if that is further allowed to pass through another tourmaline crystal which is having optic axis at particular angle with respect to the optic axis of the polarizer, then in that case the output, the light emerging out of the analyzer will have lesser intensity as compared to that light which was incident upon it. So as the angle between these two optic axes increases from 0 and finally it becomes 90 degree, the output of the analyzer becomes 0. Means we don't get any light emerging out of the analyzer. This will prove that the light which was incident on the analyzer was a plane polarized light. Now if we think about incidenting a circularly polarized light or elliptically polarized light, what will happen is the output of the light emerging out of the analyzer will have lesser intensity, but it will not be affected by the angle between the polarizer and the analyzer. So this is all about the polarized light and how we are going to detect it, how we produce the polarized light, how we detect it. Polarized light will is finding great application in our day-to-day life also. So we shall be talking about this thing and some another laws based on this topic. We shall be talking about it in the next lecture. That's all for today. Thank you and have a nice day.